Hello, everyone. Welcome and thank you for joining us for this next installment of the JAVAD virtual workshops. My name is Nima Ashjay, the Chief Design Officer here at JAVAD, and I'll be moderating today's session. I'm joined today by senior members of our sales team, Vladimir Zhukov and Michael Glutting, to first discuss a couple of new products and then show some real-world use cases, such as building and managing your own RTN using our NetHub software, as well as NetView and modem. And taking advantage of some of our receiver products to do that. I see some of you have submitted questions through the registration form for this webinar. We appreciate your submissions and we'll certainly address any unanswered questions at the end of the presentation. And as always, feel free to enter your questions into the chat box on the webinar app on your screen. And we'll address all your questions during the Q&A session at the end. So without further ado, I'll hand this presentation over to my colleague, Vladimir Zhukov.
Dear webinar attendees, dear friends, my name is Vladimir Zhukov, and I have been working in the Research and Development Department of JAVAD GNSS for over 15 years. Today, we will talk about the new JAVAD GNSS OEM products. Recently, the TRE-3S bot became available for ordering on the company website and through dealer channels. The bot is called a state-of-the-art GNSS solution for system integrator. We talk about it in the next few slides. But first, let's remind its predecessor, because scientific and development JAVAD school and continuity are the key factors on the modern JAVAD GNSS product design and the way we are looking at the future. Many of you might be already familiar with the TRE family, which are based on the Euro card format. The first representative was the TRE-3S board, released in 2007, and it was very popular among system integrator of OEM solution. The first generation, based on 216 chips, was incredibly successful. It was one of the first GNSS receiver in the world supporting Galileo. Also, the first time in the GNSS development, the universal tracking channels approach was applied. The boards were produced in 1, 2, and 4 antenna versions, also for hiding and attitude determination. In year 2015 came the second generation based on TRIUMPH-2 864 channel chip. No one in the world has ever produced such a number of channels. Deployment of new GNSS systems, rapid development and implementation of new GNSS signals, the new challenges like real-time spectrum monitoring, anti-spoofing, and anti-jamming requirements were market-driving factors of the development of such a unique technology. On this slide are shown the most famous users of the TRE family: Delayer, GFZ, Orocopter, FGI, Teles, and others. And finally, in 2021, the newest board, the TRE-3S, was released. At the heart of this board is a third generation TRIUMPH-3 874 channels chip. We will talk about its other unique properties next. The main design criteria were unique GNSS performance, excellent field reliability, and low power consumption. All the sub-goals were achieved. The company paid big attention to the cost reduction of the product to offer to system integration also a good competitive price. TRIUMPH-3 chip is based on 28 nanometer technology, utilizes 874 GNSS channels, which allow taking all current and future satellite signals. Hundreds of thousands of equivalent correlators for fast acquisition system increase its performance up to multiple times. The ultra-wideband fast sampling and processing and programmable digital filters of the main selection provide excellent out-of-band jamming protection. Taking features of TRE-3S, this all GPS, GLONASS, Galileo, Beidou, including Phase 3, QZSS, including L6, Indian radio navigation system, including S-band. The unique feature is the independent taking and use of the system. Now, the market request is not only to process all GNSS signals together and select their best combination, but individual, efficient use of every system becomes an important application for many customers. JAVAD GNSS was the first who could provide RTK solution using GLONASS only, with completely disabled GPS tagging. Today, our customers use for high precision positioning, heading and attitude determination not only individually GPS or GLONASS, but also Galileo and BeiDou. And we know that this issue is still not have been addressed by many of our competitors. The mechanical and electrical interfaces of TRE-3S didn't change. The board is form factor and interface compatible with TRE-3, 3N, G3T, and others. So it means all existing users of TRE family could upgrade their system and migrate to the new TRE-3S port with minimum development cost. The wide input voltage range from 4.5 up to 40 volts allows connecting of many external host systems and simplifies system design essentially. The board is shock and vibration resistant and complies with MIL STD 8 and 10H method 514. Power consumption of the board is below 4 watts. Flash memory on board is 64 gigabyte. It allows weeks of raw data storage. Interfaces available also require only high level of a system integration for engineers. So 4 serial ports allows connecting of many sensors like temperature, pressure, external radios. 2 high-speed USB ports connecting with local PC, USB flash drive, Wi-Fi module, cellular module, Bluetooth module, and others. Ethernet, easy including the local and global network. PPS event for special timing receivers, medium and big size drones, photogrammetric application. Additionally, external reference frequency input-output, min-path interface, and configurable GPIO ports are available. Next features to pay attention by system integrators: fast acquisition channel, spoofing and jamming detection, jamming or in-band interference rejection, spectrum data output, improved advanced multipath reduction, inbuilt web interface net browser, up to 100 Hz RTK, RTPK functionality, essentially increased Ethernet and USB speed. And more available from JAVAD GNSS house is open GNSS receiver external interface specification, which is open and published on JAVAD website as information for system integration, individual project support, and system design advices and consultations directly from JAVAD team, from JAVAD developers. Let's discuss fast acquisition module on the board on the chip. The fast acquisition module is designed to quickly search for a navigation signal, determining the shift in carrier frequency and the shift in code latency. Unlike the signal searching for conventional GNSS channel, the FA processes a pre-recorded in-memory signal in non-real time, which speeds up the search in the proportion to the clock speed in the signal processing block. In particular, for the TRIUMPH-3 chip, the acceleration is about 130,000 times compared to the one correlator. FA module is being also used for jamming and spoofing detection. Different type of interference may cause a lot of problem for a user in the field. The source of interference could be intentional or unintentional. The type of interference could be in-band or out-of-band or both. Initially, intentional interference was applicable mainly to special applications, for example, military. But today, unfortunately, it presents more and more in a daily, usual commercial operations. JAVAD GNSS developed efficient methods which protect receivers, TRE-3S board particularly, so they can survive a different interference, in-band, out-of-band, or both. We will discuss today in-band methods. For out-of-band, refer to our J-Shield technology. Jamming is an intentional type of in-band interference. Its goal is to suppress the GNSS signals. To determine the presence of a jamming situation, the software evaluates the noise level in the overall search range. If it exceeds a certain level, which is empirically defined and which is typical of a normal interference situation, the program indicates that the jamming condition is present. Spoofer is also an intentional type of interference. It replicates GNSS signal. It could be considered as a type of attack based on falsification of navigation signals. To determine the spoofing presence, the software analyzes the entire dataset of the results of signal processing module. If two or more correlation peaks are detected, a decision is made about the presence of spoofing. Advanced spoofing and jamming protection is included in the base configuration of TRE-3S board. So the system provides the following information: tracked signals that are successfully tracked, used signals that are used in the positional calculation, spoofed fake GNSS lag signal detected, jammed signals that are influenced, suppressed by jammers, jammed and spoofed, the real signal is jammed and the fake signal is put on top of it. The indication of spoofing and jamming using NetView and modern software is shown on this slide. Yellow is jammed signal, orange spoofed, pink spoofed and jammed. So it's a real situation which was recorded in one location in the world. In-band interference rejection or anti-jamming. So detection of jamming is one case. If you detect a jamming, you can just exclude the signal from position calculation. So it exists another technique. In-band interference rejection. In-band interference have a dramatic effect on the quality of receiving the navigation signal, up to complete impossibility of reception. An effective mechanism to fix such a problem is to suppress the interference with various filters. So not just detect, but I would like to stress this is to suppress, to remove the interference from spectrum and allow navigation receiver to calculate position in such conditions. It should be understood that suppression, cutting of interference without significant degradation of the navigation signal itself is possible only if the width of the interference spectrum is much less than the width of the incoming signal spectrum, usually more than 10 times. To suppress in-band interference, the TRIUMPH-3 chip has a special module, anti-jamming filter, based on the principle of adaptive LMS filtering. The TRIUMPH-3 chip implements 16 identical filters, and this allows customers to use them in parallel in different frequency channels with corresponding GNSS channel connected to them. The only disadvantage of anti-jamming filter is some increase of power consumption if it's enabled, but if it's not needed, anti-jamming filter is turned off. On this slide, we see some examples of anti-jamming or IBIR, we call this operation. For example, 4 2 MHz interferences, 200 kHz width of each. Red line shows IBIR anti-jamming mechanism off, green anti-jamming enabled. The difference in noise floor of both graphs is about 30 dB. So 3 dB, it's 2 times in power. So you can calculate it's a huge amount of power which and interferences with anti-jamming modules remove from signals and allow TRE bots work in normal conditions. Another example, 4 2 MHz interferences, 20 kHz each. Gray IBIR off, purple IBIR on. Maybe it's difficult to get impression for spectrum, so let's check for signal to noise ratio. When jammer is enabled on this table, the number of satellites tracked reduced from 13 to 9. Signal to noise ratio for satellite number 11 for example, dropped from 33 to 28 to 15 dB. From BDS number 12 from 51 to 35 or for 16 dB. So this is very strong jammer. And when IBR is turned on, the number of satellites tracked returned to 13, to initial number of satellites. So all 4 lost were recovered because of anti-jamming system. And signal to noise ratio dropped only for 3 dB, which acts almost not sensitive by the receiver during its operation. So anti-jamming system recovered the receiver and allowed its normal operation under strong external interference, which actually it's not controllable by the user. So anti-jamming operation summarized in the table. So interference divided by its effect in the 3 categories: small, medium, high. So we can see for small interference means input signal level about minus 55 decibel per milliwatt. So if IBR is off for small interference, number of satellites doesn't decrease, but signal to noise ratio decrease. When IBR enabled, SNR comes back and it's no difference. So receiver works absolutely identical, like external interference doesn't exist. So effect removed. If it's interference in medium, number of satellites decrease, SNR decrease also. We enable protection, number of satellites comes back to normal, as the signal to noise ratio decrease, but not so just for 1-2 dB, which could be such decrease could be ignored. And for strong interference, the satellites almost not tracked. So it's even we don't talk about SNR because it's decreases to level to very low level. When IBR protection enabled, signal to noise ratio decrease, but satellites come back and receiver can work and do and process with positioning calculation. So next nice feature, which also relates to interference monitoring and environmental checking, spectrum data output. The spectrum data output allows outputting the data to display the spectrum of GNSS bands to visually estimate effect of different in and out of band interferences. The use of this option is very easy in TRE-3S board. Even system integrator without RF radio frequency skills, which actually are majority of system integrator, will be able to check environmental. During a system design and integration, different power and signal circuits could affect performance of GNSS board. And checking spectrum for all bands should be standard practice for all system integrators. When you design power supply for external, when you design any host system, you buy external CPU. This all could create a lot of harmonics, which actually would affect performance of your GNSS receiver. And of course, IBR functionality will remove many of your interference you created during your system design. But it is logically to leave IBR for external interferences, which are out of your control. So customer can visually analyze the graphs in NetView modem and make a decision about the presence of the interference and its influence on the signal tracking. Next, we will see few examples of spectrum taken from TRE-3S board using NetView and modem software. So wideband 1, we see clear nice spectrum for GPS L1, GLONASS L1, and BDU B1. On next band, it's GPS L2, L5, GLONASS 3. We see it's clear etalon ideal spectrum, which actually used to compare performance or influences of different jammers or different intentional or unintentional interferences on your GNSS receiver. Wideband 3 shows GLONASS L2, BDU B3, Galileo E6, QZSS L6 narrow bands, within one wide band, which we call wideband 3. And to confirm that TRE-3S board tracks all bands, including very unique RNSS S-band, here is a spectrum taken from S-band, which is about 2.4 gigahertz. It's and spectrum taken also from L-band, from Inmarsat B narrow band channels. I have finished my part here. Thank you very much. My colleague Michael Glutting will continue the presentation.
Hello, everyone. My name is Michael Glutting, and I work in sales at JAVAD GNSS. I've had the privilege of working for JAVAD companies since 1994. And in those more than 25 years, I've got to say this new TRE-3S and the Delta-3S that result from it are one of the most capable GNSS receivers that I've ever seen. I'm going to take a few minutes, or hopefully not too much time. I'll try to go fast, but I want to share as much detail as I can about the system, about a way that you can use it to immediately start taking advantage of some of the features and functions that it has. The TRE-3S and Delta-3S can, of course, support an enormous variety of positioning, navigation, and timing applications. We could spend a few hundred hours together discussing all of them, but I don't think you have that much time to share with me today. In this half of the workshop, I want to demonstrate how incredibly easy it is to unleash the power of a JAVAD reference station and to provide RTK corrections and store observation data for post-processing later. When you consider that some RTNs charge $2,000 to $3,000 a year for RTK corrections, or if the network doesn't have a base station that's close enough to your work area to provide you with adequate performance, or finally, if you simply don't want to have to set up a base station all the time, just build your own RTN. It's actually very, very easy. The first step, of course, would be installing your GNSS antenna. For fun, I have a couple of examples here of antennas that are installed. One on the left has been on our roof in San Jose, California for about 10 years now. It's a bit dirty after being up there for that long, but it's still running great. On the right-hand side is a new installation by one of our land survey customers in Northern California. And if you look closely, you can see that it looks like they've repurposed their DirecTV antenna mast for this installation. But as long as it's very sturdy, you're going to be able to get very good results out of your system. First, you want to connect to your receiver via, let's say, USB or serial to configure the internet, configure the IP address, default gateway, and network masks so that you match the settings of your local network. Then you can use either the default ports for our system for transmitting those corrections and connecting to the receiver, or you can choose your own if you prefer. Here to the right, you also see the port that you would use to connect to the web interface of the Delta receiver. Next, you would enter your base coordinate and correction type. To compute an accurate base coordinate, you could collect a few hours of raw data. The new TRE-3S and Delta-3S have an enormous 64 gigabyte memory chip, which will store data for literally months or possibly years, depending on your epoch interval. But for this, just collect a few hours of data and submit those JPS observation files to our free depot service for processing, or you could use whatever post-processing service is available to you in your region. Then configure one of the available 5 TCP output ports to stream out those RTK corrections. And here in this example, I'm outputting an RTCM3 MSM short message, which will have GPS and GLONASS, Galileo, Beidou, even QZSS corrections if you want. Next, you would need to configure port forwarding on your router. Everybody's router is going to be a little bit different. You want to look up your manufacturer's details about how to set up that port forwarding, but set the port forwarding so that you can connect incoming connections to your internet service provider's connection directly to your device within the network. It's pretty easy to do. There's even a nice YouTube video example there at the bottom to show you how you can do it. Then, if you don't have a static IP, which most of us don't for our home or our office, you can configure dynamic DNS. In this example, I'm showing you a cool name that we created that's just called javadrocks.dnsdojo.org. There's a lot of different DNS names that you can select, so you can come up with something that's short and easy to remember. And then if ever your IP address changes because it's dynamic, this service will automatically, with the support of our dynamic DNS capability inside the receiver, update that IP address to point to the DNS address. And the service is only about $55 a year. And then finally, once that's done, you are streaming out corrections to yourself or to any of your fellow users. One single Delta receiver without any additional software or any server, no PC, no anything, just a connection to the internet, power, and that antenna can stream corrections out to hundreds of RTK users. But let's say you don't want to just stream those out, or you don't want to just stream them out for free. You want to have a little bit of control over those corrections that are coming out, or you want to have the ability to support the industry standard NTRIP transmission. We have a free NTRIP caster built into our NetHub software for this purpose. NetHub runs on a Windows PC. It's a Windows application, and you can use it to manage an entire network of JAVAD GNSS receivers. It controls and configures the receivers, performs automated tasks, of course has that NTRIP caster built in, and it can be configured to automatically push data to FTP servers or to JAVAD's Depot server. All basic controls for controlling the receiver are of course supported. You can upload firmware, upload options, upload and download files, change configurations. You've got a lot of automated task capabilities here. You can set the system to record raw data files locally to your local server, or again, push them to FTP, or push them to our server, the Depot server, or convert them into Rhinex format for use by other users outside of the JAVAD community. The active tasks can of course be monitored to make sure that everything is progressing as it should. Here it's quite interesting. If you're pushing data files to FTP or to depots, these files that are sent to depots, our server, are made available to the public and can be used when post-processing rover data using our depot service. So that means if you are in the state of Ohio and you're in an area that doesn't have adequate coverage, you could augment the system by setting up your own reference stations, and then JAVAD's Depot service will use those local base stations to post-process your solution. NetHub has a full-featured NTRIP caster. You can use it in simple authentication mode, or you can set it up to have individual accounts. Each base station can be individually configured, and you can decide what kind of corrections, what correction types you want to be allowed to be output. Here's an example of a source table. I'm sure many of you have seen source tables with your various software packages. This is a great example of the automatic mount points that are created by our system. Auto 18 there, for example, would automatically connect you to the nearest physical base station in your network and then begin streaming out RTCM3 MSM corrections to that rover. You have very nice control of the individual client accounts. You could use this to set access. You could use this to sell access to individual RTK customers. And here you can see all of the connected clients at any given time. And you also have a nice error log to let you know if one of your users is having trouble connecting. You can work to troubleshoot that problem. And you can even see these connected clients on a real-time map. And then finally, you've got a continuous log of all of the user statistics. NetHub's NTRIP caster is in use worldwide, from large-scale regional networks to one-person surveying firms. Here's an example of the city of Glendale, who uses this service in and around the State Farm Stadium. They manage that facility and they manage the area around it. And they have users who are many JAVAD receivers, of course, to go and perform work, but occasionally they have contractors that come in that have some other manufacturer's equipment, and we use NetHub to be able to supply them with RTK corrections, and not only for precision work, but also for GIS applications. There is a brand new feature that is just amazing and I think is going to be incredible that's been incorporated into the TRE-3S and of course the Delta-3S. It now packs the power of RTPK. So much like our Triumph LS, Triumph LS Plus receiver, and the Triumph 3, the TRE-3S includes support for the powerful RTPK option. This combines the strengths of RTK and PPK into one system that can post-process your RTK data and verify its results in parallel and in real time. This means that you essentially have the full power of our RTK engine, which has been evolved for decades. And now on top of that, in one little box, you also have the full power of our new Justin 3 post-processing software. This gives you the best of both worlds and provides unmatched confidence in the receiver's positioning solution. This feature will be very useful in a wide variety of structure monitoring applications. The Delta-3S will be available in 3 different variations, depending on your input and output requirements. And here's just a couple of images of what they look like. The top one will be the base model with the GNSS antenna connection, TNC coming out of the back, and then of course the various ports coming out of the front. And then on the bottom, you have a GNSS antenna input, event marker 1 PPS, external frequency input output, some other options depending on, again, what inputs and outputs you're going to require for your application. The base configuration of this receiver is absolutely packed with options now. Many of them Vladimir Zhukov was mentioning, like spectrum data output, spoofing detection, in-band interference rejection, a massive 64 gigabyte memory chip, and many more options. Here's a list of a few of the options that will still be optional for purchase, including RTPK. The update rate will be a standard of 20 Hertz RTK and 20 Hertz update rate, but you can increase that to 50 Hertz and 100 Hertz if required. And of course, for the OEM board, you will have the option of selecting a conformal coding option if you require that for your application. These receivers and this board are available for purchase now and are shipping right now. Also now available for purchase is our Grant receiver in OEM form factor. So these are OEM antennas that you can build into your own systems. They're based on our Grant G3T and our Grant G5T, and you can see the different tracking capabilities that each antenna has. And we know that this will be very useful to some of our system integrator customers. We're looking forward to it. Where to purchase the system? We have a really nice brand new dealer locator. So please take advantage of that to find the nearest dealer or agent to you, or just email us at sales@javad.com. And we've got a new offer based on this TRE-3S. We call it the TRE-3S Development Kit to enable system integrators to move forward as quickly as possible with this new technology, the new TRE-3S. We've created a promotional development kit. You purchase one TRE-3S at the standard price of $4,500, and you'll receive a second one and the evaluation kit at no additional charge. So the first unit, of course, could be set up for use in your lab or office environment. And then the second one, instead of having to move them back and forth, the second one can be used for your physical integration into the system in the field. We are always interested in building relationships with quality companies. If you'd like to join our dealer or agent team, please visit our website and click on Become a Dealer. Thank you so much for listening to our presentation. Vladimir Zhukov and I would be very happy to take your questions now.
Thank you very much for that detailed presentation, Michael and Vladimir. So at this point, if anyone has any questions, please feel free to either enter them into the chat box on your screen. There's also a raise your hand feature in GoToWebinar. If you click on that, I can unmute your mic and you can speak with us and ask your questions directly. So whichever way is most comfortable for you, please go ahead and let us know if you have any thoughts or questions about this presentation. Ahead of time, we did receive one question that seems to be a common question that we get, and is can we get an overview of the TRIUMPH LS Plus? That while that's not relevant exactly to this webinar, we do want to point out that our friend and agent Sean Billings did a workshop recently. I believe it was last month, possibly the month before, but that workshop is available on our YouTube page. So that's just as with all of our workshops, including this one, you can always go to our YouTube page and see what information is there about past workshops, and just use that as a repository of very useful information. Okay, we have a question from Brad. My map on my NetHub doesn't show users any longer. Is there a setting that needs to be changed?
That's a good question, Brad. I'm not sure what the answer to that is. I'll have to get our support team to take a look at that. I'll follow up with you directly. I'll send you an email. And if you could just send me a screenshot, perhaps, of what you have there to sales@javad.com or michael@javad.com, I'll follow up.
Great, thank you for that. So another question, what about NetHub? This project is live now, so can they use it now, or is this a beta, or is it coming in the future?
No, it's available now. It's on our website, and in the presentation there was a link to it, but it's very easy to find. If you just go to JAVAD's website, hover over the menu button, and go to software, you'll see it on the right-hand side. So just go ahead and download it, install it, and then begin connecting to whatever JAVAD GNSS receivers you have.
Excellent. Is there a map of the existing JAVAD RTNs on the website for potential end users?
No, we do not have a JAVAD GNSS RTN service at this time that's providing those types of corrections. What we're sharing today is information about a software package that each individual user or dealer could set up, or municipality or city or state could use this software to have a network of JAVAD receivers and then share that data. I'll check and see if there's anybody who's making that data available for free. It would be really nice, actually, if we could share that on our website so that we could at least direct you from our site to those local regional providers.
Great, thanks for that, Michael. Do you have some news about JAVAD's Webcaster?
Yes, we have some news. The next firmware release will include a netcaster for receiver. For now, you can use temporary netcaster from NetHub, but receiver very soon will have this functionality. I think it's a matter of maybe 2, 3, 4 weeks max.
Great.
That's awesome, Volod.
Okay, one more question. The new NetHub features that were shown will be added by the free update, or do you have any plans to transfer NetHub to a paid basis?
Oh, good question. Yes, there are a couple of features in there that are new, that are beta, and they will be released and they will be free in the next version of NetHub.
Excellent. Okay, if there's any other questions, please feel free to put them in the chat box or raise your hand. I see we have Adam might have a question here. Let me unmute your mic, Adam. All right, go ahead, Adam.
Hey, Nima. Hey, Vladimir. Michael.
Hey.
I have a potential customer that would like to set up the Delta-3S as a base station at their office. This webinar will be a good resource for getting the settings and everything. Is there some publications about setting it up, Michael?
That's a great question, Adam. I will look and see. We have some resources, but they're spread out over a couple of different places. So, of course, we have an extensive GRIUS guide that talks about all of these different parameters, but it doesn't go through them necessarily one by one. So I think it'd be fun to put together a quick start guide that walks people through this process. There'll be a couple of steps that are outside the realm of JAVAD GNSS, like I talked about for port forwarding, but those things are pretty easy, relatively easy now. And of course, the DIN DNS service is a terrific service and will make your customer quite happy with what they've put together in their office. I look forward to it. So good question, Adam. I will look and see what's available. I'll gather it all in one place and we'll put together a quick start guide for you.
Great, thank you.
You're welcome.
Good webinar.
Thanks, man.
Yeah, thanks, Adam.
Thank you.
Cool. All right. So with that, I think, again, if you have any more questions, feel free to email us, and we'll be posting this webinar on our YouTube channel again. And please stay tuned to our website and to our newsletter. We'll keep you up to date on future plans for webinars. And if you have any topics that you'd like for us to cover, again, please email us. We'll incorporate that into our schedule as best as we can, because we want to provide you guys with the content that you want to see and that will be helpful to you.
Oh, Nima,
yeah.
We just had one more question pop in at the last minute. Vladimir, could you address that question? Can you see it there?
No, Michael, could you read it, please?
Oh, Nima, I'll leave it.
I got it. Will the TRE-3S have new multi-RTK capabilities or more engines?
Actually, yes, it's already has. It's a different, it's different RTK engine, but it's as good as engine in LS Plus. It's but it fits needs of OEM customers and. But yes, I think it's 6 engine already running on board of TRE-3S and RTK. Yeah. So to configure it now, it's for example, I think JAVAD Mobile Tools, Delta could be configured and controlled from JAVAD Mobile Tools, but Net View and Modem allows you to configure and play and set up all this multi-RTK mode also. So it's only a question for system integrator. Usually they build their own applications to interface and to use the functionality of a board. But the answer is yes, yeah, it is supported.
Great, thank you for that, Volod. Okay, that looks like all the questions for now. So we look forward to hearing from you all and looking forward to seeing you at the next webinar next month. So we do these once a month, the last Thursday of every month. So looking forward to seeing you all at the next one. Thank you so much for joining us today. And thank you, Michael and Volod, for your time.
Thank you. Thanks, everyone. Thanks for watching.
Thank you.
Okay, see you all next time.